Air conditioning and ventilation arrangements at underground Delhi metro stations. For supply of fresh air and removal of body heat, as well as heat generated from electrical equipments in train, a system of air conditioning and ventilation underground provided known as Environmental Control System, that is ECS. The ducting, dampers, grills and diffusers, etc. are spread across the entire station to provide fresh, cooled air to maintain adequate freshness, temperature and humidity inside the station. 800 to 2,000 tons of air is provided at every underground station. The four main components of ECS systems are air handling units along with ducting, trackway exhaust fans, that is TEFs, chillers, and cooling towers. Let's talk about air handling units. These are connected to a supply air shaft and having a blower and cooling coils. The blower is used to supply the air which is passed over the coils carrying chilled water. This cool air is then circulated in the entire public area with the help of ducts and grills. In winter season, there is no supply of chilled water and AHUs simply supply outside fresh air inside the station. Trackway exhaust fans. The function of a trackway exhaust fan is to recirculate the air. They extract the air from UPE and OTE and supply it back to AHUs or discharge it to the atmosphere depending upon requirement. Chillers are the most important component of air conditioning arrangement. They are responsible for operating three different cyclical processes. First is the chilled water cycle. In this cycle, chilled water is continuously supplied by chiller's evaporator to the AHUs. This chilled water absorbs the heat from the air and returns to the chiller. Second is the refrigerant cycle. In this cycle, refrigerant is continuously absorbing heat of the chilled water in the chiller's evaporator and rejecting its heat to the condenser water in the chiller's condenser. And third is the condenser water cycle. In this cycle, condenser water is continuously supplied by cooling tower. This condenser water absorbs the heat of the refrigerant in chiller's condenser and returns to the cooling tower. Next component is cooling towers. Cooling towers are heat removal devices used to transfer waste heat to the atmosphere. The heat gained by condenser water in the chiller's condenser is removed in the cooling tower for reusing the condenser water in a cycle. Here you can see the entire environmental control system of an underground station. Tunnels in underground stations are also enclosed areas and may require ventilation in case of any critical situation. Therefore, underground stations are also provided with a system of ventilation inside tunnel known as Tunnel Ventilation System, that is TVS. The main component of tunnel ventilation system is tunnel ventilation fan, that is TVF. Each underground station has 4 TVFs on each line. Now, in this system, the fans work in combination. That is, in case of any critical situation inside tunnel, fan at one end of the tunnel will work in supply mode and push the fresh air inside tunnel, whereas the fan at the other end will work in extract mode and pull the air from the tunnel. Therefore, these tunnel ventilation fans are fully reversible. There are 3 modes of operation of TVS: normal, congestion, and emergency. First, normal mode. Normal mode means everything is normal in station and tunnel area. The TVS equipments are in off state but ready for any operation. However, when a train comes, it brings a draft of air due to piston effect. Therefore, in tunnel ventilation system, a method is devised to reduce the effect of this draft of air. Plenums connecting both the tunnels are provided in the system, as can be seen here. When train brings draft of high pressure air, some air escapes to the other tunnel, thereby reducing the piston effect. Second mode of operation is congestion mode. Congestion mode of operation of TVS is mode corresponding to situation when train stops between two stations for extended period of time in the tunnel. Now, trains are provided with air conditioning system for passenger comfort, which releases hot air outside. This will result in a slow and steady increase in temperature in the surrounding of the train. When the tunnel air temperature in the vicinity of the train AC exceeds beyond a limit, the AC units will trip, causing discomfort to passengers. In this mode, air is pushed in the direction of train movement by operating the TVF of rear station in supply mode and extracted from the other end by operating the TVF of next station in extract mode. Third mode of operation of TVS is emergency mode. Emergency conditions are the TVS operational mode for smoke conditions in the tunnel. In case a train is unable to proceed, the passengers are to be detrained in the tunnel, for which smoke-free passage is made available by operating TVFs. Let's first see the case of rear fire, that is, front evacuation. In case of fire in the rear of a train operator will plan for detrainment of passengers from front of the train. In this case, the TVF of next station will run in supply mode and TVF of rear station will run in extract mode. This will cause the smoke to move towards the rear station and passengers will be able to evacuate to the next station in a smoke-free environment. Tunnel ventilation system also consists of a shaft going up to the ground level. The smoke going to rear station will be discharged to the atmosphere through this shaft. Now let's see the case of front fire, that is, rear evacuation. In case of fire in the front of a train operator will plan for detrainment of passengers from the rear of the train. In this case, the TVF of rear station will run in supply mode and TVF of next station will run in extract mode. This will cause the smoke to move towards the next station, where it will be discharged to the atmosphere through tunnel ventilation shaft.